some helpful. So I guess this is the second part. Some helpful graphs to have in your brain, in your mind box, are the natural log. That's for sure. And the reason for this is you can now, like, if you have this in your brain, you can evaluate limits with the natural log fairly easily. So it crosses the x-axis at 1, 0. That's this point right here. It never touches the y-axis. So the limit, so the important limits that come from this are, first, you can't approach from the left side because natural log doesn't exist on the left side. If you had the absolute value of x, then it would be the same thing. But you can think of that later or whenever you need it. So it goes to negative infinity, and then also as x approaches infinity, the natural log goes to infinity. That's a useful graph to have in mind. Also, sine and cosine, those are useful graphs. I guess not just for limits, but for everything else. Sine, cosine, tangent, arctangent is one that comes to mind. When you're evaluating limits with sine and cosine, sometimes it's useful to know that they just oscillate back and forth between 1 and -1. So those are important to have. And that kind of, here, I guess, especially with the vertical part, kind of brings us to asymptotes and holes. So I'm going to write down some stuff for those things. For the graphs, when do you have a hole? So what I want to say is when the denominator is 0 for whatever x value, but cancels out with a term in the numerator, then you get a hole, discontinuity. For example, here the denominator equals 0 when x equals -1. However, you can factor this so that one of the terms cancels out with the denominator, and now I don't have 0 in the denominator, but this means I have a hole at x equals -1, which means this graph, it looks exactly like y equals x plus 1, except for we have a hole at x equals -1. That's because for every, like, you think, wait a minute, well, wouldn't it look like a curvy because it looks like a quadratic divided by something? No, it won't look curvy. It'll look like a straight line, because for every single value that's not -1, these two things cancel out. For an infinite number of values where x is not equal to -1, those cancel out, and you just get this. So really, you're just graphing that. And then when x equals 1, you're not allowed to have that. So, or sorry, when x equals -1, you're not allowed to have that. So there's a hole. So that's why it just looks like a line when you graph it. If you have 0 in the denominator and nothing cancels out, then you have a vertical asymptote. So if nothing cancels out and you're asked to find the vertical asymptotes, just take the denominator and set it equal to 0. For whatever values you find, just make sure it doesn't cancel out on the top part. Then that's how so you would have a vertical asymptote at x equals blank, or at x equals, whatever x value makes the denominator 0 and the numerator not 0. And vertical asymptotes, those are going to be like y equals something. You take the limit as x approaches positive or negative infinity. If you get like infinity, then you don't have any vertical asymptotes. It just keeps growing. Or if you get negative infinity, it just keeps decreasing. But if you actually get a number, then you do have an asymptote. I suppose you can have like a diagonal asymptote, but that's usually reserved for trig pre-calc. I haven't seen that on an AP exam, so we're not going to talk about that. Yeah, there you go. I'm hoping that that's enough to get you through the assignment. But yeah, we'll have a little bit of time for questions, and then we'll move on. And that's how it's going to be. That's all we're going to do. Okay? Okay, goodbye.